Well, good morning, everyone. It's a lovely Dayton day outside, which we like to have whenever we have visitors in town. We have a few things to update about our various time frequency, software-defined radio, GPS, and all sorts of merges together projects this morning. And first, I'm going to start with the one that's not really great news. Last year, we introduced a 4-port GPS GNSS antenna splitter called the GUS, and it was designed to be a very inexpensive way to have multiple receivers off of one antenna that does not have the filtering that most splitters have that limits it to only using the L1 band. This is broadband, and we'll do L1, L2, L5. It's been very popular. It works well. A lot of people like it, but I chose an extremely tiny low noise amplifier chip, barely visible under the microscope size, but it was specifically designed for GPS applications and seemed like just the thing. It turns out that the company that we have manufactured the boards, JLC PCB in China, has had a lot of difficulty soldering those parts down and getting them to work. And we've had a chance to have some of the boards X-ray inspected, and there's kind of all sorts of different failures. It's just the pads are too small, they can't position and get the solder paste down properly. So we've had a failure rate of about 1/3 of the boards, which we've been pre-testing now, so everything that we send out to a customer works, and this doesn't seem to be a problem with intermittence. It's either going to work or it's not going to work. So we have products for sale. They will be fine, but my project right now is to redesign. There are lots of other low noise amplifiers available, and they may not be quite as optimized for this application, but they can do the job. So we'll be doing a new circuit board that uses a chip that will be more reliable to solder down, and hopefully it won't impact the availability at all. Hopefully it won't impact the price. It's just a design change that we'll have to make. New project that we've been working on is the GERT, which is a GPS DO, except I tend not to use those words in describing it because it's a little bit different than the traditional one. Interestingly, it came from a designer whose focus has been RF rather than timing. So he wasn't thinking about how you divide the pulse per second and do long phase loops. He just wanted something that would drive a software-defined radio. So Glenn Elmore, N6GN, came up with this board that is designed to be good enough to be the reference source for an HF SDR, like a Kiwi SDR or the RX888 receiver that you may be able to see at our booth, and it's become very, very popular, that need 27 megahertz or 66 megahertz clock frequencies. So Glenn's board was designed to meet that need. It has 2 outputs that can be independently set for the frequency, very low cost, and it's just a way to get the frequency reference that'll work through HF. And actually, he's been using it for whisper at 1296. So it's actually usable up into VHF as well. We're redesigning the board to make it a little bit more modular and to do what we called when I was working cost-reduced value engineering, which is that Glenn used one component that's very expensive, and we're trying to replace that with a much less expensive one to lower the cost. And if that works, we're hoping that we'll be able to sell this for less than $100. That's compared to about $170 for the Bodner Mini GPS DO. And I'll tell you up front, this is not as good as the Bodner, but it's good enough, and if we can make it down near half the price, we think it's something that people will be interested in. We have hardware that works, although we're still tweaking it, but the big problem is that Glenn used an Arduino IoT33 Arduino board that has a built-in Wi-Fi chip. And he did that because this was originally part of a much more complex multi-band transceiver project that he's worked on, and the other pieces also used a web interface. You don't really need that to set up a GPS DO. You're just setting the frequency and a couple of other things. And that Arduino board costs like $25, and there is no clone available that has the Wi-Fi and the right number of I/O pins and the other stuff to be able to drop in. So we've been looking at a lower cost module. We think we found one. It's about $6. It looks like it can use the same chipset, so we don't have to totally rewrite the code. It has enough I/O pins, but there's a lot of work in modifying the code from using the Wi-Fi interface to using a serial port and all the other minor changes that the hardware changes require. George, K9TRV, has been leading the effort on getting the software ported. And again, we're close. We have hardware and software that almost work together, but not quite. And once we get a couple of more things worked through, we'll be able to actually put the new hardware, the new Arduino clone module on the board. And it shouldn't take much beyond that point to have something ready for sale. So I'm hoping that by the end of the summer, before the next DCC, we'll have these available. But keep your fingers crossed, because there are a few hurdles that we have to overcome. The next thing I'd like to talk about is not really timing related, but you get there through one or two hops. Whisper Demon and Whisper have become extremely popular for HF propagation spotting and even up on 6 meters and higher frequencies. And there are a couple of radios that have become very commonly used for that. The first are the Kiwi SDR, web SDRs, because they can not only have real-time users connected, but they can be monitoring several bands simultaneously to decode Whisper. And then about a year ago, this thing called the RX888 started appearing. And if you've been around SDRs for a long time, we used to talk about there being a software-defined radio and then finally a software radio. And the software radio was where you just had an analog to digital converter that went right into the computer. You didn't have to have any big FPGA processing or anything. And that's really what this RX888 is. It can receive DC to 60 megahertz and essentially just turn that into bits and shove it down a USB 3 port into a host computer. Phil Karn's KA9Q radio interfaces with that. So you can take one of these RX888s, which you can buy for about $160, and connect it to a modest PC running KA9Q. You can record every Whisper band that there is, as well as tune around shortwave, as well as record signals from WWV and CHU, and the thing's just loafing with dozens, even hundreds of decoders. It's really cool. But because the radio is so inexpensive and so basic, it's got a few things that it needs some help with. The first is thermal management. It gets pretty darn hot, and the heat sinking in the as-delivered version isn't great. And you can do a bunch of things to sand down the heat sinks and get better thermal conductivity, but the biggest improvement is just to use some better, fatter thermal pads on the chips so you get better contact with the case. So you need to do that if you don't want the thing to blow up. The front end, it's essentially a digital to analog, an analog to digital converter. And even though it has wide dynamic range, et cetera, it still needs some help before being exposed to the real world. So you often want to have an isolation transformer to keep common mode noise from getting out or from getting into the receiver. You may also want to have filtering to reduce broadcast bands, strong signals, and things like that. So you want to have some kind of front-end treatment. Then the 888 will also use an external 27 megahertz reference, and with that you can get extremely accurate frequency control. In order to do that, though, you need to put a tiny UFL connector, plug that pigtail into the board, drill a hole in the end plate for an SMA connector, hook it up, and then if you don't do it right and put DC on that pin, you blow up the clock chip inside and it's not good. So we need a nice interface board that makes that easier and less painful. So 3 or 4 different bits and pieces that you can put around one of these radios. Most of them would also work with the Kiwi SDR. And Paul, WB6CXC, who has a little company called Turn Island Systems, has been working with Whisper transmitters for quite a while, and he's showing off in our booth 6-band Whisper called the, I think it was called the Beacon Blaster. I think the name's changed now, but 6 Whisper frequencies simultaneously with about a watt each. Paul's also designed some of the stuff that we need to attain the RX888, including the thermal heating pads, a little reference board interface that provides the kind of coupling that you need and protection against DC, and he even made a new end panel with the hole already in it for the SMA, so you don't need to drill any holes. TAPR has done, along with a lot of other people, a little antenna board with SMA connectors at each end that has a 1-to-1 transformer that simply isolates the coax shield from the radio to help reduce noise that's being brought in on the outside of the cable. So we're going to offer all those things together as a single kit to go with an RX888. Don't know the exact cost, but it's probably going to be $40, something like that. But it will be everything you need if you buy a 888 to turn it into a very good radio. And I'll also put in a plug. Paul has developed some other filters and front-end LNAs for the 888. We don't know quite yet how they're going to be sold. He may sell them through his business, or TAPR may sell them for him. But they're very nicely designed and very reasonably priced. So if you're interested in the RX888 or any other wideband receiver where you want to pick up the whole HS spectrum, but also have to deal with AM broadcast station noise and FM broadcast overload, Paul's got some neat stuff for that. And we'll hope that those will be available inexpensively quite soon. And beyond that, we have a couple of things in the works. I have a board that's designed, and it's actually came out of the RX888 project, but it's 4 digital outputs from 1 input that's buffered and can take anything from like a -15 dBm signal and turn that into 4 nice clean logic outputs at anything up to 100 megahertz. And it's in the same form factor as the Gus antenna splitter, so the same case will work. We'll have those available, I think, by the end of the summer, if not sooner. And Scotty already mentioned a tiny NTP server, which I think is a really cool idea. There are lots and lots of NTP kits around. You can buy hats that will go on a Raspberry Pi and things like that. But using the Pi Zero makes it very small, and it hugely reduces the current draw. So this thing can run off of batteries for the weekend. So really, really helpful if you're doing field day and have digital stations where you need to have all the computers lined up. This will be a great thing to throw in the bag and give you timing when you're away from home. And that is about it. So happy to take any questions or turn it back to Scotty.